Happy Monday! Welcome to our third week of notes in Unit 1. This is the last week of notes looking at conversions using dimensional analysis. So far we have studied the intro to chemistry, looking at what is chemistry and its different branches. Then we did measurement types, estimation, significant figures, scientific notation. And this week we're going to be covering conversions. So the first thing we need to look at for conversions is defining a conversion factor. And a conversion factor will be helpful because it is going to put different units related to one another. And we're going to call that an equality expression. You have seen these already with metric conversions, like 1,000 milliliters are in 1 liter, or like time. You might have, 60 minutes in 1 hour. You'll see them written like this often with an equal sign. It's our equality expression. And we are going to use these kind of like a bridge between the two different units. In this example, minutes and hours are the two units that we will be bridging together using this conversion factor. When you are reading a problem for conversion, some type of word problem, you will want to look for certain words that will identify a conversion factor. So you might see the word per, like there's per miles per hour, or of course equal. In every, maybe you're saying there are 12 inches in every foot. Or each, there are 100 centimeters in each meter. Those are some words to look for in a word problem conversion factor, per, equal, in, every, each. We will use these conversion factors in a series called dimensional analysis. And dimensions are another word for units. So we're going to be doing a unit analysis, really, to use these conversion factors as bridges until we reach the desired unit. So this method converts units. So it's our method of converting units using conversion factors. They're going to be our little links. And as we go through, I'll show you this in the diagram, it'll cancel like units diagonally until we reach our desired unit. When you do a dimensional analysis problem, always start with the given. Okay, always start with the given as it's written in the diagram below on its own in the first part of your diagram. The reason that dimensional analysis works is because it is a series of multiplying by 1 through these conversion factors. Remember, they're equalities. So when you have a fraction with a number over a number and they're the same number, it's equal to 1 and it won't change the value of what you're working with. So we'll use a series of multiplying by 1 with different units in order to convert between them. And we'll write the conversion factors as fractions to accomplish this job. Okay, so let's take a look at this canceling of diagonal units. If you have highlighters or colored pens, go ahead and grab those out, or even crayons would work, while I pull up some colors here. So let's start just kind of color coding this diagram. Our given will have a certain unit. Let's say we want to convert from meters to feet, okay? So if our given unit is meters, I'm going to write these down just as an example here. So this is meters. Then our unit needs to match diagonally to cancel on the bottom of our next conversion factor. So that would also need to be meters. Then we would use a bridge, maybe meters to centimeters, and we know that there are 100 centimeters in 1 meter. That would be our conversion factor here. Let's use another color for centimeters. So this top part now is centimeters in our conversion factor. The next step, the next bridge or equality conversion factor that we use would then put the same unit now on the bottom so that they will cancel out, centimeters on bottom. And maybe we then convert to, let's say, inches. That would be on the top. And then our final conversion factor would put that same unit, inches, on the bottom. And then we can use our last conversion factor to link to feet on the top. Let me go add in our example units here. We said pink is centimeters, and then we turned green for inches. The relationship between inches and centimeters is 2.54 centimeters in 1 inch. And then inches are green. To feet, what equality do we know here? Well, we've got 12 inches in 1 foot. Okay, so there's our process of conversion factors. Our given could be really any number of meters, and then we can have this work to be able to find what the feet would be. When we would actually calculate this in our calculator, we would take all the numbers at the top of our fractions and multiply them, and then all the numbers at the bottom of our fractions and divide our value by them, because these are fractions. Multiply and divide, hit equals, and you will solve your problem. Okay, I would probably put this in my calculator like this. So whatever my given is, let's say it's 5 meters, okay? So 5 times 100 times 1 times 1, there's all my top numbers, then divide by all the bottom numbers. And you can just do this all in one string because of the communicative property of multiplication and division. Also keep in mind, multiplying and dividing by ones is unnecessary. I wrote them in here so you can see all of the work, but by the identity property, you don't need those because they'll just be the same number. So in your calculator, you would want to just pop in your numbers, hit equals, and you'll have the answer. Let's take a look at an example word problem for doing the work of a conversion problem using dimensional analysis. Katie has 240 beads to make bracelets. She plans to use 15 beads per bracelet. If she gives 2 bracelets to each of her friends, to how many friends can she give bracelets? Color code matching units in your work. All right, when we're looking for conversion factors, that's the first part of our work, we are going to be looking for a per, equal, in, every, and each. I see per here, and I see each here. Look for those first to identify conversion factors. This first one says there are 15 beads per bracelet. So our equality expression is 15 beads equals 1 bracelet. The other one I see, 2 bracelets to each of her friends. So our equality is 2 bracelets equals 1 friend. There's our equality expressions that will help us bridge from the given to the find. Let's identify those now. Once you have determined all of your conversion factors, usually the given will just pop out as the last number. Katie has 240 beads. There's our given. That's where we are starting. And the find is usually written as a question, or it might say find so-and-so. How many friends can she give bracelets to? There's our find. How many friends? Okay. Now we can sort of see our bridge come together. We've got beads, so our unit needs to match beads. Here's an equality expression we have that will link beads to bracelets. Then we can follow that with bracelets to friends, and that will be our final unit at the end. Let's go ahead and write this work down. Start with that given always first, including the unit in your work so that you can track them and match them. So 240 beads. Then our conversion factor that we'll use first is the beads to bracelets, because it's the only one that has beads in it. We have to match. So we have 15 beads equals 1 bracelet, and we're writing this as a fraction. This is a fraction here, technically multiplying by 1 in its value so that we're not changing this, but in our 1 we have a different number, kind of like 12 inches are in a foot. It's equal to each other but different units, so we are going to have different numbers in there. And our last bridge, bracelets to friends, again match your unit. Previously used on the bottom, new unit on the top. Then you can put this in your calculator. 240, the ones are unnecessary, divided by 15, divided by 2, and you will get 8 friends. Just a little side note here, if you're ever using real items or people, if you get a fraction, round it down so that you have a whole number. That way you have how many people you can actually give bracelets to, and then you might have some left over if it were to come out as a fraction. On the back side, you have some conversion problems with lots of different conversion factors listed down at the bottom. As you work through these, you'll use those conversion factors to convert between the given and find. For each of these, as you go, just draw a horizontal line, and then as you find your pieces of information, plug it into your little train tracks. How many minutes have passed if it has been 150 seconds? 150 seconds would be our first spot here, the given, and then we're just going to start finding conversion factors that will link a bridge until we get to minutes. Well, we know that there are 60 seconds in 1 minute. Oh, look at that, we only needed 1, and you didn't need this part, so that's fine. You can just cross it off or leave it if you have extra space, and then put it in your calculator. 150 divided by 60, and you'll get your answer. So that's what you will do for each of these 6 problems today. Have a good day.